Okay, so we're back talking about section 3.3, and I'm up to number 14 now. This one's a little bit, takes us back to a little bit from the beginning of the lesson to the factor theorem to decide if this is a factor of the first, but some of these later ones have videos you can click on with it, I guess is the difference, but you've done some like this earlier in the lesson. So to decide if x plus 5 is a factor of this polynomial, notice it has the x on it, so we change the sign to minus 5 for synthetic division. That's the k value, and then write out all of the coefficients and make sure they do x4, x3, x2, x1, x0. No places are skipped, and it's in descending order for synthetic division to work. We bring the first term down under the line, then multiply, and then add. Multiply, add your way across, and I get a remainder of 8. So that means no, it's not a factor. Whenever you have a remainder, that means it didn't go into that polynomial evenly. All right, number 15, the question is to factor this polynomial given that k equals 5 is a 0. So that k equals means don't change the sign. It's already in k value form. And then write out your coefficients. Nothing is skipped there. Said 5 was a 0, so I expect. Then this is quadration. Because x squared to begin with, polynomial divided by an x to the first every time in synthetic division takes it down 1 degree. So that's 2x squared plus 3x minus 9. You can factor that the old-fashioned way with the reverse of the FOIL method puzzle, or if you like synthetic division and some of the methods we've been using, you can guess and check to try to find the zeros by repeated synthetic division. We know if it's factorable, they're all rational zeros. So we know that the rational zeros comes from factors of 45 over factors of 2. So it has to work with that. But I'm going to do it the old way by the reverse of the FOIL. And I know the signs are different to get a negative 9. I'm going to guess, I'm trying to get a 3 in the middle. 3 times 3 there is my first thought. Then when you inner, and outer, and combine those like terms, it's negative 3x. I needed a positive 3x, so that's not bad. You just have to change these signs, reverse them. So that factors, always refoil and make sure. But the factored form, don't forget to pick up this one, is x minus 5. If 5 is a 0, then x minus 5 is the factor. Then our new factors we got from our quadratic, 2x minus 3 and x plus 3. So that's now a completely factored polynomial. Number 16 is, again, we've seen these. I guess maybe the rest of the questions we've seen a form of that already in the earlier questions. Watch the video, so it gives you another video example here to find the possible rational zeros. So that's factors of 35 divided by factors of 1. And 35's factors would be 1, 5, 7, 35. And then it could be positive or negative of those, divided by factors of this lead coefficient, which is just a 1 here. And the only thing that goes into 1 is 1. So everything divided by 1, we'll just have those numbers plus or negative. So that looks like answer B. Then for the next part, you have to figure out which ones work. So we start through our list. I know it can't be too many zeros. Zero is a polynomial, so you can have three answers, 3 solutions. It's one of these, maybe positive 1. And remember to go back to your original polynomial, the coefficients, and see if it works. And I just am lucky in that it does. So 1 works, so I'm kind of suspecting answer C, but I'll go ahead and verify that by using 5. There should be up to 3 zeros. When you do 5, also note you get a 0 remainder. And then lastly, negative 7. Negative 7 gives me a 0 remainder. So C it is. Now, if those are the zeros, then to factor it, we just change the sign. X minus 1, x plus 5, and x plus 7. And that would be factored form of that original polynomial. Number 17, that's that long problem that we just did earlier in the last video where you have to work backwards and find the original polynomial. So given these zeros, more paper. The signs will change to x plus 3. That will be x plus 1 and x minus 4. Now, if you see this clue, that means you also are responsible for figuring out the lead coefficient. That's the clue for any lead coefficient. It doesn't affect where the zeros are or the x-intercepts, but it might turn it upside down or make it a wider or skinnier graph. All right, and this is y, or f of x, equals. This f of negative 2 equals 18 means when x is negative 2, y will be 18. So we fill in y is 18 over here, and all the x's as negative 2's. And then we'll be able to solve this equation for a to figure out that lead coefficient. So this is all about just figuring out a, simplifying each one of these parentheses. That multiplies to be 6 times a equals 18. Divide both sides by 6, and you're able to solve for a as 3. So now we know to put 3 right there in front of that polynomial. That's its lead coefficient. Then the answer, it says do not, in fact, you can't write the answer in this form. Unfortunately, it wants it simplified all the way. So multiply all of this back, believe it or not. So I usually multiply the last two to work my way here because I'm the number bigger and have to 3 to the step. So multiply it in any order you feel like, though, but this is just me. So this FOIL method. And then you'll have some like terms to combine. So that's the answer for this times that. So I'll mark that. Still need to incorporate the x plus 3. I'm saving the 3 to last, like I said. So this needs to be multiplied. So I need to distribute x times all 3, then 3 times all 3. That just really means multiply all the combinations there. So x times x squared is x cubed. X times minus 3x is minus 3x squared. X times minus 4, no, minus 4x. Then distribute the 3 through that parenthesis. Combine any like terms that you see. These two actually cancel. And then I combine those and get x cubed minus 13x minus 12. This looks so much like a problem we just worked, doesn't it? Then lastly, I have the 3 in front. I think on the other one I had a different number to distribute on the last step. But very similar, you might notice, to one we did earlier. And then that is your final answer, your polynomial of degree 3. And now we know everything you could want to know about this. So when we get to the next section, 3.4, we're going to be graphing these polynomials. So now we know what the polynomial looks like. We know that the last number, when it's in this form, is its y-intercept. We know where it crosses the x-axis at -3, -1, and 4. Those are its zeros or its solutions or its x-intercepts. And we will be able to know like the end behavior of the graph too, which we'll talk more about in the next section. All right, then the last problem, number 18, is also a doozy. Kind of takes a little extra work on that one too. And you've seen one like it. It was earlier in your homework. This one's just got an attached video is the only difference, I guess you could say. So let's look at it if we have time on this last video. It says its leading coefficient is 1. That's kind of a gift because we don't have to fit a value. But it has zeros of 5 and 4 plus I. So a 0 of 5 will make it x minus 5. But the amount of zeros are sort of a pain. It'll be x minus. Instead of just a number, it's a quantity 4 plus. So I will need to distribute my minus sign there. And then what's inferred if you have an imaginary 0 is that its conjugate has to also be a 0. So if 4 plus I works, 4 minus I has to also be a 0. And then that will be y equals our polynomial. So all of that needs to be multiplied together, which, and I love algebra, and I even think this is a pain. But I would need to distribute the subtraction sign. Again, once you know what the zeros are, like for 5, we just say x minus 5, and that's fine. But if it's an imaginary number with 2 parts, it's x minus that imaginary number, and the minus sign needs to distribute into that imaginary. So it kind of complicates it, but it changes the sign of both parts of the 0. you could say. So here, same thing, makes it x minus 4 and plus I. Then all that times together. I recommend, just from experience with these, if you multiply these last two first, it'll clean it up a bit. So how do we multiply this times this? Just a lot of distributing. The x times all three, the negative 4 times all three, and the negative I times all three. It's just a lot of distributing. Every combination multiplied together. Just try to watch your spot as you go through to get everything incorporated. So I systematically go through and distribute each one of these terms, watching my signs. And I should have 9 total terms. There's 3 terms times 3 terms, making 9 total terms. And then reduce in any way that you can combine. One thing is I squared. We always know that I squared equals negative 1. So we have a minus negative 1, so that's going to be a plus 1 on the end now. Then we have a positive xi and a minus xi will cancel out. Let's see. We have a positive 4i and a minus 4i that goes out. We have a minus 4x that makes minus x. And then a 16 and a plus 1, which is 17. So it kind of cleans up nicely. Like I have in the past, I knew that those two together will make a nice quadratic. So I multiply that. Still times it by the x5 factor. So to multiply that, I distribute this times all three, this times all three. So just a lot of busy work in this little section. So distributing the minus 5. Okay, what is 5 times 17? Is that 85? 35? Yeah. So minus 85. Combining any like terms, we've got x to the third alone, minus 8x squared, and minus 5x squared is minus 13x squared. 17x and 40x is 57x, and then a minus 85 on the end. All right, and that's the last part of it. That's what we put inside this simplified answer for number 18 or something like that when yours regenerates. All right, I hope that helps.